Hi everyone, welcome to Spark Summit 2020. Today I'm going to present you the quality of service demo, which is a solution that we actually open source and you can find it on GitHub, which I'm going to show you later. And today I'm going to take you through the architecture and through the benefits of the proposed solution, and also show you a demo of the quality of service. My name is Andrei Avramescu. I'm solution architect at Databricks, aligned with the media vertical. So basically, I work with the biggest accounts or customers in the media vertical, and the solution is basically based on it's based on the best practices that we have seen in the field. So, firstly, I want to take you through the infrastructure. The infrastructure, as I mentioned, is based on a mix of best practices around Databricks and what we have seen in the field, and the best practices from AWS. On the left side, you can see the web player. Basically, the web player is one of the two sources of data that are used in the proposed solution. The web player is just an application where all the user actions are basically being captured, and beside that, there are also we are also gathering metrics around the network traffic, which of course are used afterwards for deriving insights around the service and the system. The other source of data is basically the CloudFront, the CDN logs. So CloudFront allows you to dump all the data in S3, and we are using something called Databricks Autoloader to ingest that data into Delta in order to get better performance when querying the data. Of course, in the middle, you see Databricks as a unified data analytics platform, and we have actually targeting the solution, in the proposed solution, a few different aspects of a unified analytics platform. Firstly, we are talking about reporting and analytics, which is a must. Even if we talk about the root cause analysis, or which is basically ad hoc analysis of the data, or we are talking about dashboards that we want to publish in order to show to the business what's happening inside the system. From reporting, then we are moving towards machine learning. The second big use case is machine learning, and usually when I talk to my customer about machine learning in this space and what I've seen by them implementing, is they start at the infrastructure level with trying to predict the traffic inside on their websites, on their platform, moving from them to actually spreading the traffic across the network, across different CDNs, in order to provide a better quality. That's really important specifically for live events, when you have platforms that are streaming live events. And that's the first infrastructure layer. But then on top of that, because they have similar kind of web players where they are capturing all the user behavior, all the user events, they are looking to do content recommendation, and afterwards, of course, we can look into churn analysis and trying to understand, when we have a customer that is going to leave our platform, what should we do? The last part of the system that you can see on the top side is basically a complex event processing engine. So usually data scientists are going to tell you, oh, you don't really need a rules-based engine inside the system. You have machine learning, which is not actually true. We see a lot of use cases where they just want to send a notification. They just want the real-time analyze the data, and then maybe send an email to a certain team, or maybe to update some dashboards. And for that, we are using best practices from AWS, which recommended to have a publishing subscribing system. We are using Amazon SNS for that, and pushing that notifications through Lambda, and updating the real-time web application, and of course sending emails. From the infrastructure part, I'm going to move to the data view, and I won't spend a lot of time on that because there are a lot of other sessions at the Spark Summit discussing about Delta and Delta architecture. But one of the most important things that I want to point, and the reason why we have chosen to implement a Delta architecture for the QoS solution, is the fact that offers you a unified batch and streaming architecture. For those who are familiar with Lambda architecture, people tried for a long time to get rid of that. You have two different layers, the fast layer, and also, of course, you have the batch layer. And because of that, we used to have, when you implement the Lambda architecture, so many issues around having two different pipelines, having to maintain them, having to deal with the latency. With a Delta architecture, where you can imagine everything as a stream, and then you have different layers, bronze, silver, gold layer, that you can see also in this diagram, but every table is a Delta table, and that allows you to basically stream from a table, and in a streaming fashion to take data from a table and push it to a different table. And then if you really want to be a batch, you can use something called trigger once, which is going to execute just once the whole ETL processing, all the processing. So it's basically like a batch thing. Okay. If forgot to mention about Delta, but basically Delta, for those who are not familiar with Delta, is an open source storage format, which is basically which brings C transactions and scalable metadata handling on top of your normal storage format like Parquet or ORC, and which allows you, of course, to get all the you get that unified streaming and batch processing. In terms of what data resides in each layer, bronze, silver, and gold. Bronze is your raw data. You just dump data from Kinesis, Kafka, or other system. Silver is basically the data where you expose data to everyone, and I like to call those the pipeline which brings data from bronze to silver, the make your data available to everyone pipeline. So when you get into the silver layer, everyone should be able to read the data from there. Data should be anonymized, and I'll show you an example how to do that. And then at the end, you have the gold layer, which is basically specific tables or databases for reporting, or even for AI, or in different use cases. And before actually going to the demo, I want to take you a little bit just around the advantages or why this type of architecture actually works. When you want to build a QoS solution. Most of our customers, when they implement QoS, they want to reduce the latency of the data, and this is a huge requirement from them. I want low data latency. I want to see exactly what happened inside my network, and by having a single technology in place, like like you have in a Delta architecture, and not multiple different stacks, then you can reduce the end-to-end pipeline SLAs from the ingestion to the query point. There is this defining of latency at runtime thing, which I'm going to come back later. But basically, you don't really have to define upfront if you want to run this, the ETL or the pipeline with a frequency of seconds or hours. And then latency is good, but then latency, usually having a low latency is great, and you can build the best system, but usually that's really expensive. So with a Delta architecture, you also get a really low cost. And the reason for that is basically you don't have to maintain two different type of pipelines. You don't really have to maintain two different pipelines. You have decoupled the compute and the storage, and but also because you land the data inside Delta Lake from Kinesis, you're going to reduce your cost on the Kinesis side. And actually, this is not really a problem with Kinesis, but it's rather how these queuing systems are being built, how this type of systems are being built. Because if you add more consumers, then you'll have to scale the number of topics, brokers, and so on, and that's going to increase your cost. But if you land the data immediately in a Delta Lake, and in a Delta table, then you can have any number of consumers that you want, and you just pay for the computer. Don't really have to scale the storage. The last but not least important is, of course, the machine learning side, and creating more or better machine learning algorithms. And why is this important? Because none of these customers are actually using Databricks or any system just because they want to do something cool on with technology. They want to have better business outcomes, and data science is the closest point from my perspective to the business side. So what's actually going to impact your business is most of the time having really good machine learning algorithms. And with this kind of architecture, basically you get more resilient data sets, which is going to improve your accuracy for your models. You'll reduce the time to market. by using MFlow. MFlow is the end-to-end machine learning lifecycle tool, which is offered as a managed solution in Databricks. So you get that the built-in support, and there are even auto-logging and other kind of features that are already implemented for you there. So we have even seen customers moving in production in like 2 weeks, developing a machine learning algorithms and actually making money for the business, which is amazing. And the last bit, of course, on the machine learning side is around how you increase the productivity with the collaborative environment based on notebooks. But that's something which probably most of you are already familiar. So now what I want is to actually move to the demo. And for the demo, the first thing which I'm going to show is basically this web player. I mentioned it. This is the application which is used, which allows you to play different movies. So I can go here and play this video, which is Tears of Steel, or I can choose a different video. And then I have on the right side 3 different widgets. The first widget is just the number of active users. Right now it's just myself. It's just 1 active user. You see the total views, and then you have the metrics which are captured. So basically all the information around the traffic over the network, as I mentioned to you, which is captured. So having this UI, then you can play and pause the movies. These are the kind of actions that I was talking about. So all this information from this UI is then pushed to Kinesis. And if I go now inside Databricks, we have the landing page inside Databricks. And for those who are not familiar, this is our interface. You have the workspace where we have all the notebooks. You have data, where you have our dataset clusters, which are basically the infrastructure required to run your code, jobs, a way to actually schedule all your machine learning or data pipelines, and the models, which is the model registry that allows you to version your machine learning models at the end, and making sure that you get into production only the best models. Now, if I'm looking at the structure of this project or the QoS solution, you'll see that it's composed of 5 different notebooks. I know, and we have a lot of discussion with our customers of why use notebooks, or why or when using where is the best, when and how is the best way to use notebooks versus using old software engineering patterns and packaging your apps like jars or like Python wheels. The idea is with notebooks that you have a much more collaborative way. And as I mentioned before, we see that the adoption of notebooks is, it's increasing, it's growing. We see much more adoption lately. And that's why we decided also to implement the QoS solution using notebooks. The first one is just basically like an utility having some variables. The second notebook is it's basically just creating all the tables. I can actually show you that. Let me show you all the notebooks. And then I guess there must be some connectivity issues here. But if I go back to the initial setup, you'll see this is basically just SQL scripts creating all my tables, bronze table, silver table, so on. So it's just creating the structure. Now from the initial setup, then if we move to the data preparation step, and this is where I'm going to show you a little bit about the pipelines which are ingesting the data to bronze, which are moving from bronze to silver, and so on. I want you, as I said, you can find all of this on GitHub. It's and I'll show you the link, and you can get all the notebooks. I just want to point a few different things here. One, this is basically how the pipeline which is taking the data from Kinesis and landing it Delta in an append-only table. So we just append everything, all the messages from Kinesis, allowing us to use basically a Delta table as a stream afterward to have multiple consumers reading those events. And it's pretty straightforward to do that. You just have to use the built-in connector for Kinesis, define the Kinesis stream name, and then basically you can read the data. Cool thing about using Databricks is actually the fact that all the security is good. It's done through IAM roles, which are attached to your cluster, so you don't really have to add any username or password, and you won't see any username and password in these notebooks. So it's pretty neat from that perspective. In this case, once you have pushed all the events into a Delta only append table, then you can move and say, okay, so I have my bronze layer. In this case, I'm going to have my bronze layer as a Delta only append table. So in order to move from bronze to silver, I'm going to show you the pipeline, which is for the CDN logs. So if the first one was the player events, the CDN logs, as I told you, the logs are dumped into S3 periodically. So what I would like is to have a way to ingest them automatically and clean the data. And you can do that. You just have to define a UDF. This is a standard UDF, but you can use Pandas UDF to improve the speed and make the processing faster. But this is the simplest way possible to do stuff. You have a UDF, user-defined function, that in this case that is mapping an IP to a location, and I have another function which is just anonymizing my IPs. And then with autoloader, the only thing which I have to do is basically I'm going to say I'm going to receive all of my data in JSON files. It has the schema, load from certain bucket, and then I'm going to apply the anonymization. Of course, I don't want to have any issues with GDPR or other kind of regulations. And then I'm going to add another column which is going to map my new IP, which is anonymized to a location, in this case to a country. I'm doing that just because I want to be able to provide reports at the country level in this case. And then I can just write that back to a Delta table, really easy. In this case, I just configure this as with that trigger once, which I mentioned to you. Probably you guys are familiar with that. But trigger once is going just to run this query once, and then I can schedule this as for example, as a batch job. Otherwise, I can just let it run every, I don't know, seconds or minutes. Configurable, I can configure the frequency, and then files are going to be automatically being processed. From this perspective, probably some of you are already familiar with this pattern, which is used by the autoloader, which is basically having an SQS queue, which gets notification about the new files. So you don't, this is basically, the autoloader is going to do all the setup for you to use the same best practices around processing only the new files. And the last bit, which I wanted to take you through around the data processing, is just how to stream from one table to another table. So I have, in this case, I read my player events from bronze, I apply all kinds of transformations, and then I'm writing back to a silver layer. So this is, again, using that same pattern, which is streaming from a Delta table to another table. And it's really easy. And then I just can update, I can update my gold tables. And once I have my data in the silver layer or in the gold layer, I can go down and say, you know what, I want to build dashboards. And this is actually the dashboard that I'm going to show you. But before moving to that, let's assume I have a team of analysts and they are building dashboards for the business. And they are writing all the code in SQL. It's really easy to do that. You can use all the tables that you have either from silver or gold, or even bronze if you want to go and use the bronze, even though I would not recommend that, because if you have sensitive data, I assume these teams, they will only use the data once the data is clean. So you have your notebook, and then you want to build a dashboard. In this case, it's really easy. You can show this dashboard, and you can even present it. So in this case, I have a network operations center dashboard, and I'll show you. Actually, it's really interesting. I asked a few friends to use the web application in order to see if I got any insights. And it's really interesting. For example, I have the unique viewers, really easy to calculate that. And then I even have a map with the location to see where most of my users have been watching my movies, views by region. And then I can even understand, how many unique views I had, and at which hour. So I can, for example, if I stream different type of, I have a high variety of videos, I want maybe to improve the infrastructure in order, based on a certain point in time during the day, to be able to focus on one video or another video if I see that there is a huge discrepancy between different type of videos. Maybe kids are watching certain type of videos between 6 and 8 p.m. Then I want to have a better way to serve that during that period, or improve dynamically my system. If I move to a little bit down here, I can see the percentage of paused videos. This is just based on the user actions, and this is really interesting. Remember when I told you about content recommendation? This type of information is what you will need in order to understand if users have watched the full videos or they stopped in the middle, even understand, and then go more in depth and understand why they have stopped the videos. Is it a problem with the bit rate, or if I go further down, I'm looking to the buffer time. Buffer time being one of the main reasons why we see 8 agencies stopping to actually serve ads in different platforms, just because if there is a lot of buffering in the video, they only lose money. People don't really want to. They don't want to wait for to add extra buffering to their videos while watching ads. Really cool here. You can see different type of browsers, and if you have a testing team, you know exactly. In this case, maybe 80% of my users are using Chrome, so you know how to prioritize your development for different web apps. And then you have, of course, the first frame or the loading time for each CloudFront edge node. So basically, CloudFront as a CDN, you have the main data centers, but then you have edge nodes, which is going to closer to the users, and then CloudFront will try in a smart way to actually optimize the way they are serving the videos. And then you have the difference between loading from origin and the edge nodes. Few different use cases where you would use this kind of analysis is to understand how dynamic origin can help you with AWS. You can basically point the edge node to get the actual video to stream from a different location based on where the request is coming from. And you definitely want to do that when you see that you have new user in a certain location, maybe add some add videos also to a different origin server. The other bit is of course the buffering time per edge location. Here is mostly, and this dashboard is basically focused on the middle mile and the last mile. So we are looking at how the encoding is affecting, and how different edge and edge and origin, how this the network traffic between edge and origin is actually impacting the performance. But we do have customers that are also looking on the first mile, so how the ingestion onto the origin server works. So you basically can, as long as you gather all the traffic details, then you can go and look into, okay, how can I optimize different parts of my workflow? You have the dashboard, and you can share this with a business person. He doesn't have to actually run any code or see any code. As long as he has a login user in the platform, you just provide him the link, and then he will get, if he goes in the platform and you basically share the link, then he will be able to access the dashboard. Now, if I move from the dashboard to the real, actually, let's go first to the complex event processing engine. So sending email alerts using structured streaming. If I just want to calculate, in this case, my error percentage, one thing which I can do is I can implement again, and this is appended to the UDF, which is going to calculate the error. Think about this use case. You have applications which are running on TVs, and then a brand decides to update their firmware, and then they update their software, and that's going to impact your app. So you would like immediately, when a few people start watching, the video on that type of TV on that specific brand, to get notified there is an error. There are too many errors, in the app. It can't be just the app. I haven't changed that. So if you want to do that, you can have like a streaming pipeline, which when you run it, for example, is going to send an email to a specific team. And this is, in this case, it's just I'm running this on demand, but of course you can have this as a streaming pipeline. And once this is being executed, then I'm going to get I'm expected to get a notification just because the number of errors it's higher than the threshold which I define. So if I go now to my email and I just run, I'm having here, I can see that there is a new email, and if I open this email, I can see number of errors for this app has exceeded the threshold, which is 0885. So it's a big number. Really easy to build on top of that and to calculate different metrics and to generate different notifications. And all you have to do is basically to invoke SNS, and from there you can have multiple different subscribers. The last bit is around the real-time side, and I told you that, and this is, for example, an example of how to calculate total views. Of course, the real-time KPIs have to be defined by the business, how you measure the active users in my platform, how I define them, the number of views, and so on. In this case, total number of views for videos are updated every 10 seconds, but I can change that to even 1 second. And if I go to my web player and I start playing the Big Bucks Bunny, which is now 23, and I start playing that, my expectation is going to be then in 10 seconds when the next my pipeline is going to be executed, then the number is going to go up, and it just went up to 24. So automatically all the information is processed. At the same time, if I go back to this and I can see this data is being actually processed, I just started to watch again the video. So I watched which was a few minutes ago and then stopped. Same thing, I can look at the number of recent views or how many actually other players are watching the same movie, or number of active users, everything implemented in a streaming fashion. The benefit of using notebooks and Databricks is how easy it is to write and to implement a new pipeline. You can reuse notebooks, so you can have utilities and all those benefits, but just implementing and running a new pipeline and testing it's pretty straightforward, while you can have your own CI/CD pipeline. So once I have this real-time basically view, which is updating the number of active popular videos, I think we have actually covered now the reporting and the reporting side, and also the complex event processing side. On the machine learning, we are actually working right now to extend the repo and expect to see an example of how to use MLflow and for content recommendation or for other use cases. Meanwhile, please make sure that you guys are going to check the other sessions at the Spark Summit. There are a lot of interesting talks which are going to cover all the important use cases across the media industry, but also in the other verticals. Thank you for your time, and hope you have enjoyed and you have a great time this year at the Spark Summit.